All right, let's have some math fun. Normally, I'm doing mind your decision videos when I do some of these math things. The last one I showed you, it's what I called the escape room, and it's how we programmatically or systematically find our way from one room to the other. And we use the best invention in mathematics of all times. Of course, that's my opinion, linear algebra. But every once in a while, you've got to use something else. So here's one. Why did I pick this one out? Well, it was in my feed, so blame YouTube. It's not me. I'd never heard of Math Queen before, 201K subscribers. I guess I don't get out much. At the end of this video, which I won't play at all, I'm just going to freeze it here because this pretty much has all we need to discuss. But if you want to see how she solved the radius of this incircle on the trapezoid, I'll put the link down in the description. And she asked at the end, how would you do it? Well, let's just understand something here first. All these mathematic channels on YouTube are designed for the layperson. So, you know, at best you have high school, grade 9, maybe grade 10 mathematics. You've probably forgot most of it. So it's a way to try to bring it back for us old folks. So it's not meant for mathematicians or engineers, obviously, because you know, they are well advanced in this field and they just know this stuff, and they would not do it necessarily like this, but of course they use the tools that come out of this, whether it's explicit or not. And so she had said, how would you, or how did you solve this if you were working on this and it was different than hers? So what we're going to look at today, and I'm speaking quickly here because we need to get it done, we're going to look at two different ways of solving this problem. The first one is what I would call the fun way. You wouldn't really do it like this, but you could. And it gives you a different way of thinking. Maybe you can apply that to some mathematics in a future problem that you may or may not have. It's kind of cool. It's linear algebra-like, kinda. I'm stretching it. But that's why it appeals to me. So let's get rolling. So what do we have here? A right-angled trapezoid. And this circle is tangential to all four sides. So here, 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 that's given. The one of the bases, the parallel length is 3, and the second one is 7. All right, so how would we look at this in a manner that isn't like what she described? Well, and it's kind of linear algebra-like, and why I say that, I simply mean it in the fact that linear algebra does a decent job solving systems of equations. So if we can get two equations on something like this, we've got an easy find. So what we're going to look at, the families that involve this trapezoid. So a trapezoid has obviously a relationship of 3 sides to the 4th. So here we're given length 3, length 7. If we only had the other one, you can understand without any mathematics that you would have to, by very nature of a trapezoid, it's a closed figure, you would know this length. And that would be just basic mathematics. So if we could plot all of the available right angle triangle lengths, h, all right, this height versus the length of this slanted line, you would have a family of 3, 7 trapezoids. Okay, you could plot it all on a line because the relationship between this height and this slope is a fixed constant ratio. And that ratio is given by this formula, right here, c equals square root, and that right there. Now, you don't have to memorize that. You could figure that out just by looking at this formula here. But as a matter of fact, you have figured it out because this is nothing more than the Pythagorean theorem. So you see this dashed green line here. She just scooched that height line over here, and you created a Pythagorean theorem out of it. Now, down in her comment section, there were some people doing some hillbilly math, and I kind of laughed at it because they somehow thought this was a 3, 4, 5 triangle. Yeah, slow your roll, think again. I don't understand. That was an unforced error. There wasn't a time limit on you having to figure that out, and you still got it wrong. So you would have a family of right-angled triangles that would satisfy this formula right here that I keep mousing over and it keeps changing, right? So what I'm getting at here, and by the way, that's a family for 3 7s only. So this might be one of them. That type of thing where you get a height of 9.65 and you can just work out what length of BC here is, right? So if you did that, you would plot a line, a curvy line, of all possible right angle Pythagorean theorem curves with lengths 3 and 7, which is what we have here. You would get a line like that. So that's one equation. Now, what she did here was very cool. 3 minus r for the length here. And this is coming out of a formula. And you could do the same thing over here. And she did it here, 7 minus r for the green. Now, a lot of people didn't see that, didn't catch it. She didn't name it by name. But this is called Piot's theorem. Now, Pitot was French. I'm English. So if I was hacking it, I would call it Pitot. So, hey, it could be Pitot. But let's make it sound fancy like we know what we're doing and call it Piot's theorem because it's French. Sounds French to me. And Piot's theorem suggests that you can do this little spot right here and this spot here and the other two, and you get an equation that states the length of the two opposing sides when you sum them equals the length of the other two sides when you sum them. So you could say that 3 plus 7 is 10 has to equal the length of this side and the length of that side. And that will give you a second line that you could also plot on this particular curve here. And that's where you get this linear algebra like comparing two systems of equations. And when the two lines cross, you get your solution, because this is a solution of all possible right angle trapezoids of lengths 3 and 7, which is what you have. And if you plot only the Pitot incircles, so only the ratios of height and the length of this slanted line of any quadrilateral that has an incircle, you get another line, and where they cross, that's this right here, is your solution. So as you can see, h equals 4.2, c equals 5.8. So h is the height. So I just got this green triangle here, which matches this one over here on the right. So h would be the AD line. Obviously, the radius, which is what she's looking for, is 1/2 of h. And that is kind of a cool way of doing it. So you get two different families, and where they cross is the only solution for your specific problem. Again, you wouldn't do it like this in real life, that's for sure, but it's a way of thinking. But if you were an engineer, how might you do it? And again, on the right here in the comment section, somebody said, well, I'm an engineer and I'll just use SolidWorks. And yes, he's right. You wouldn't even have to know. You just draw it in there. You just draw your shape and it tells you. All right, we're not going to go quite that easy, but that is really the easiest way. If you can use a CAD program, you got it nailed. I'm going to give you something that would fit a lot more like a mathematician would look at it. And it's something called the harmonic mean. Now, this comes up a lot. I don't have any diagrams for you, so you're just going to have to listen to the verbiage here. Harmonic mean. It works for right-angled trapezoids, so you have to have two of the bases, or the lines, have to be parallel. And if that works, you get your solution way the hell easier. And the solution is 2AB divided by A plus B. So A and B are the lengths of the parallel sides. So it's 2 times 3 times 7, and it's all divided by 3 plus 7. Right? And that gets you your harmonic mean. So you have already all the available information you need in just the lengths of the two sides, and that gives you the diameter. So that will give you 4.2. So you can do the math here. 3 times 7, 21 times 2 is 42, divided by the sum 10, 4.2, that gives you your height. That's called harmonic mean. Harmonic mean is just another way of computing a mean that actually comes up a lot. I'm going to give you another example. If you drove one way 60 kilometers an hour for an hour, and then you came back at 30 kilometers an hour, what would be your average speed? And you find that average speed by using the harmonic mean. So you can see you use this a lot. So you can think of that 60 kilometers an hour going one way, that's 60 kilometers, 30 kilometers an hour going back, right? So you're 1 hour out, 2 hours back, that's 3 hours. And how far have you traveled? Well, you've traveled 60 kilometers times 2. So 120 divided by 3 is 40 kilometers an hour. That's your average speed. So you can see how actually practical that harmonic mean is. And again, you've used it before and not even known it, and it happens to work for these things. Now, don't be trying to use it for any other trapezoids that don't have parallel sides. That doesn't work. But by the way, those do fit on this pitot line, I should mention to you, because they only give you the family of quadrilaterals with an incircle. Right? So that works very well for any quadrilateral, not just these right angle ones. As long as they can have an incircle. Some can't. We won't get into that. And one other example, and I'll leave you with this, of the harmonic mean, is something that I'm a little more familiar with. If you have two resistors in parallel, right? So how you solve those simply is product over sum. So for example, you have a 60 ohm resistor in parallel with a 40 ohm resistor. Okay, what is the equivalent? So 60 times 40, which would be 2400, divided by 60 plus 40, which is 100, you would get the answer 24 ohms, and that is correct. Using this harmonic mean, you would just get double that. So in a funny kind of way, the harmonic mean, when you're doing resistances in parallel, give you the equivalent of the, and by the way, this is not a thing, the diameter total resistance, when the formula I just gave you, simple product over sum, you'll notice the 2 is missing. It gives you the radius resistance, which is what you're really looking for. So again, you find this formula or some slight derivation thereof everywhere. All right, so those are 2 ways of doing it. That second way gets you to the answer extremely quick when you have a problem like this. Again, that's not for your average person taking grade 9, 10 math or trying to get back to that level. That's not how those things work. All right, and for those of you that have recently come to this channel, I use mathematics and proven systems to play and beat the market. That's what my channel here is for. So come on over to patreon.com/Koyas Quantitative and take a look and see what we're about. Watch the rest of my videos. I come out and I give monthly summaries to keep the public up to date. And once you're inside the tent on my Patreon service, you get the whole gamut. You get trades, long, short, and you get sizing. We keep track of everything. This is a service unlike you're going to see, to the best of my knowledge, anywhere on YouTube. No one gives you the full package. That's what I'm here for. We use mathematics because there is no better way to quantify the truly unquantifiable. We keep the errors down to a minimum using proven systems that we know work. They're mathematically sound. Thus my foray sometimes into mathematics and certain YouTube channels. All right, we'll see you here.